Hello, everybody. Welcome to the video version of Physics in the Universe. This really was to help a lot of you guys out with the Rube Goldberg project. Maybe you were absent, maybe you were a little unclear on the instructions that I gave in class. This is really here to help. This assignment seems like it's hard to do, but it really is rather easy. Thing is, it's a little time consuming. You just have to be patient and work at it, keep working at it, keep working at it, and you'll get it done. So this is the Rube Goldberg, and what it does is it goes through and it shows all how work, power, and efficiency, all that stuff works. It goes through and shows about simple machines. It goes through and shows about energy types and energy forms, and how energy forms are converted from one to another. So really, this is like the final exam for the energy unit. So Rube Goldberg was a guy back, I want to say the 1920s, cartoonist who made these intricate cartoons of simple machines working together to create like a simple task, like, I don't know, buttering toast or cracking an egg, or just, it's a huge machine that did it. It was kind of ridiculous at the time, but since then we've had a lot of fun with it. In fact, there are competitions for Rube Goldberg's. World Goldberg is in the Guinness's Book of World Records. Japan has like game shows based on it. And there's just hours and hours and hours, thousands of hours on YouTube with Rube Goldberg machines that people just do for kicks and giggles. As much as I would love to go through and create a Rube Goldberg machine in the classroom, unfortunately we don't have room for these things. They take up a lot of room. So we're going to do the next best thing with this is just being able to identify the parts that we've talked about in class by watching a video. So in the assignment, so there's the Rube Goldberg assignment that you guys can see. And excuse me, well, I'm not looking at the camera, I'm looking at the computer, which is right here. There is a brief description of everything that we're doing. I put an example on there. But you look at these videos are Mr. Lee approved in that I believe by watching these, I have seen all the transitions, all the simple machines. I may be wrong, and I'll show you what to do if the video that we choose doesn't have something specifically that I'm asking for. I'll tell you what to do here in a moment. However, if we choose one of these things, or you can choose your own video, as long as you put it down here. So if you choose Lemonade Machine, you can just copy and paste that link right here. Or in my case, I am going to go, this guy, Joseph, I don't know his full name, I don't know anything about him, but I can tell you he's all over YouTube. Whenever you type in Rube Goldberg, he's already got a whole bunch of videos already made. They're usually pretty simple, and the reason I didn't use those as an example is a lot of times he doesn't have all of the things represented, particularly the energy changes. So I thought I'd kind of go through this one little video right here and show you kind of how to do it. I'm not going to do the whole project, but I'm going to take a few key points and see what's going on. So here is the Joseph's video. Now remember, we want to be looking at, well, first things first, I want to make sure I put the link. So this is one of the ones that I chose that's not on the list. So if I go to YouTube, I type in Joseph's video, I'll bring this one up, I hit share. That's going to bring this up right here. Right here, there's the link for it. I'm going to hit copy. And then I'm going to go back and I'm going to right click and hit paste. And it's going to paste that in. It's going to be important that you have that link there. Always hit space after it so the hyperlink comes up. It's always important that you have that link there so that when I go to grade this, I know what video you used. If you don't have that link there, then I don't have the time to go through and find the video that you were using. So that's going to be a very important question. Make sure you fill out. All right, so I'm looking first class lever, second class lever, third class lever, wheel and axle, incline planes, wedges, etc., etc., etc. So all those simple machines that we were doing before. So let's watch this video for just even a couple seconds. Okay, so this is called How to Destroy an iPhone, and it starts off Apparently he does not like his iPhone. He does not want to wake up, so he pulls a teddy bear. And right off the back, I can see that the hammer right here is a first class lever. The way that it moved up, let's back this up just a little bit more so we can see that hammer going up. So watch that hammer. You see the hammer's going up. We have the, excuse me, not a first class lever. This would actually be a second class lever. And that the fulcrum is at the end. The load, I even said that wrong. Third class lever. The load would be at the top and the force would be in the middle. So this would be an example of a third class lever. So a couple of things. First thing I want to note is the timestamp. We're 8 seconds into this, all right? I'm going to go back to my project here, and I'm going to find third class lever. There we go, third class lever. And I'm 8 seconds in, so I'm going to type in 0:08. That means 8 seconds in. I'm going to type in what is a third class lever. A third class lever is defined by a simple machine in which the fulcrum is at one end of a bar. The force is in the middle, and the load, which is the output force, is at the end opposite of the force. All right. The explanation, basically saying what's going on in the video. The explanation is we're using a hammer, and I forgot to look and see what's that hammer doing. All right, that hammer, what did that hammer do? Looks like it knocked something off. Oh, it knocked the phone off. All right, so a rubber mallet hammer falls to knock the phone off of the table. All right, that's all you need. So just a little brief description saying that you know what's going on. The last thing you need to do is insert the image. And so we're going to go back to this. We're going to have to go back to that 8 seconds in. There it is. And basically what you want to do is you want to insert an image. So how am I going to get this picture onto this part right here? Pretty simple, something we've used before. It's called the snipping tool, and unfortunately I'm on the wrong screen. But if you type about where this little Cortana thing is, you type snip, it'll come up, it'll say snipping tool, and it will open up. It opens up on my other screen. It'll open up a little box that looks like this. And what you want to do is you want to click on new. And I'm going to move my camera over to the keyboard like this. And I'm going to show you guys that what you want to do is you want to take a picture. You don't need to take the picture of the whole screen. You can if you really want to. But I had to click, hold down on the trackpad, and highlight just that simple tool in the video right there. I'm going to get that phone in because that's what it's going to hit. I'm going to let go. And there's my snipping tool. And from there, I'm going to just take this and I'm going to right click, push down there, and hit copy. And then I'm going to go back and close the snipping tool now. Nope, I don't want to save it. Go back to this picture right here, and right here where it says insert image, I'm just going to right click and hit paste. And there's that picture. I can get rid of that insert image there because that looks sloppy. And that's exactly what you're supposed to be doing. Get the camera working. That's exactly what you're supposed to be doing. So there it is for the third class lever. You're going to do that for each one of these machines. Then you're going to tell me, given those examples, where is a place where input has increased, input has stayed the same, the force, or the force has been decreased or changed directions. In the case of the hammer, the force was actually decreased. So you would say the third class lever in which the hammer hits phone, the force was less than the input force. And I really should have said the output force. Oops, all right, that word there. And that's all you got to put for that one. So just 3 examples of where energy or the amount of force is either increased, decreased, or stayed the same. Then we got to find an example of kinetic energy. So you write your definition of what the kinetic energy is, the timestamp at which happens. Now, kinetic energy is pretty easy. Kinetic energy is anything that's moving. So if I go back to this and I can look at this and I say, oh, let's see, let it go here. Oh, look at that, the basket's moving. All right, so that's kinetic energy. So kinetic energy is defined as the movement of objects. The timestamp, once again, I look at that timestamp and I see that it's at about 11 seconds in. That timestamp is going to be important that you get that right, because when I'm going, once again, when I'm going to grade this, I need to be able to see exactly what you're at, because sometimes the images will not be that clear. And then the explanation, the basket was moving up. That would be all I needed to put for that. For potential energy, we got to go through and we got to find something that has the potential to move. All right, I'm going to back this up just a smidge. And we see this little hand right here before we got there. Let's see. Okay, you see the little hand right there has a little weight at the top. This has the potential to move, but it's being held by this little string. When the phone hits that string right there, it's going to flip up. And that's my explanation. That's potential energy before it starts moving, has the potential of falling down and moving this first class lever. So there's a first class lever there, and potential energy and kinetic energy. So a lot of things happening there. So you would first of all define what potential energy is. That is energy, that's an object that's not in motion but has the potential to move. I would put the timestamp, the explanation, and insert the image. Then we have the energy forms: mechanical energy, thermal energy. Mechanical energy, that should be pretty easy. Most of these Rube Goldbergs are everyday objects in motion, so you can really check anything here. The hammer falling, the cart rolling into the water. All right, all of these things are mechanical energy. All right. But what about some of the other ones? Thermal energy, chemical energy, electrical energy, electromagnetic energy. So you might need to get creative in some of these, because a lot of this is, most of the Rube Goldbergs are just mechanical energy. I'm going to jump ahead to the end here. And when it gets out here, you see there's this little tank. Well, what got that little tank to move? He must have a remote control somewhere that's telling that tank to move. Well, the remote control uses waves. Well, waves are electromagnetic energy. So you could say the waves causing this remote control tank to move would be an example of electromagnetic energy. Okay, and then it comes up, and you can see right now what's happening is the tank is going to press snooze. Well, that snooze created an electrical impulse inside the phone. That's electrical energy. And the light on the phone changed. That's once again electrical energy going to electromagnetic energy. to give off light. So you might have to get a little creative and some of those things to be able to answer those, just be able to explain. Now the energy conversion, well, we just said we started with electrical energy and it turned into electromagnetic energy. So the electricity in the phone, by pressing the snooze button, caused electricity to happen, which turned it into light that you could see. And that's what you would do there. The rest of this, anytime that you see something that looks like force, define force, tell me what it is. Anytime you see pressure, the little finger pressing down on it, that was pressure. Anytime you see work or power being done, that's what you're going to go with that. And then you have your success check, just double checking to make sure you got all those parts done, and telling me where was there energy that was lost in the system, how and why. And then of course the honesty check. I want you to go through and grade. Now your grade may not be my grade, but I want you to go through and see, did you, a little check mark, how did you do on each of these parts? Because this is the parts I'm really kind of grading you on. How did you think you did overall on a scale of 1, 2, 3, 4, 1 being really you didn't get done, 2 being you got mostly done, 3 you got done good enough, and 4 meaning you felt like you did a good job. Okay, so that's it. That's what this project is. It's just a little time consuming. I'll take you guys some time, but I will give you guys class time to work on it. All right, have a great day.